Ever pondered why a rubber band stretches more easily than a metal wire, or why water is hard to compress? Well, it's time to uncover the intriguing science behind these everyday observations. Physics has the answers, and they lie in the concepts of Hooke's law, Young's modulus, bulk modulus, and shear modulus. Firstly, let's delve into Hooke's law. Named after the ingenious 17th century scientist Robert Hooke, this law states that the stress applied to an object is directly proportional to the strain it experiences, but only within its elastic limit. Now, stress is simply the internal force per unit area acting on a material due to an applied force, while strain is the relative deformation of the material. And the elastic limit, well, it's the maximum stress a material can endure before it permanently deforms. Picture a spring. As you pull, it extends in proportion to the force applied, but only until it reaches its elastic limit. Remove the force, and it snaps back to its original length unless you've stretched it past that crucial elastic limit, much like a diving board, which bends downward when a diver steps onto it, increasing with the weight until it hits its own elastic limit. Next, we have Young's modulus, which is a measure of the stiffness of a material under longitudinal stress. Think stretching or compression. A higher Young's modulus indicates a stiffer material. For instance, steel, being stiffer than rubber, has a higher Young's modulus. Moving on to the bulk modulus, this measures a material's resistance to volumetric changes due to uniform pressure. Simply said, it tells us how compressible a material is. A higher bulk modulus means a less compressible material. Take water, for example. Its high bulk modulus makes it hard to compress, a property crucial for underwater applications like submarine hulls. Lastly, the shear modulus, or the modulus of rigidity, tells us about a material's resistance to shearing forces, deformations that occur without any change in volume. A higher shear modulus means the material can better resist twisting or bending. Concrete, for instance, with its high shear modulus, is perfect for beams and columns that need to withstand these shear forces. So, remember these principles next time you stretch a rubber band or drink a glass of water. It's the science of Hooke's law, Young's modulus, bulk modulus, and shear modulus at play, defining the properties of the materials around us. These are fundamental concepts, but remember, the specific values of the moduli can vary depending on the material, temperature, and other factors. Physics, after all, is a vast and complex field filled with fascinating phenomena just waiting to be explored.